goal with this formal definition of limit is not that it is going to make perfect sense, because this is really like the first time you did a little bit of proof writing in geometry, but not much. This is your first time at even seeing a formal math proof, so I'm just trying to expose you guys to it. Okay, we're just kind of getting our feet wet, kind of seeing what it looks like. I've already told you, I'll probably put one on the quiz. What did I say about the test? Might be a bonus question. But we need to see it, because if you're going to have to take higher math classes, you're going to be seeing this type of thing more often. Okay, so I want you to have been exposed to it before. So, on all of these, our general format is kind of the same. I recommend starting out by writing your goal. And your goal is just that definition. So this is kind of like our blueprint, what we're going to do on every problem. So the definition was, if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. Okay? So the idea behind the limit is, if your limit is truly equal to L, you should be able to get as close to that as I specify. So if I give you, I want to be within 1/10, you should be able to get me there. You should be able to find an x to make that happen. So this is kind of talking about what x's would make that happen. We're trying to find a formula for it. Then our two steps. Step 1 was to find the delta. Find that x value. So we kind of worked backwards there. We started with this end part. The absolute value of the f of x minus L portion. And then we kind of did some algebra stuff, and eventually we would get a less than epsilon. And so then we knew what delta should equal. The second part was the actual proof. So in your proof, you do have to, very first thing, tell me what delta equals. If you don't have this, I will take off a point, because you're going to use that later on, so you have to tell me delta equals whatever. Then we went back to the definition. So this goal at the top, we basically rewrite that part. So if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L. And then we start working it out until we get a less than and an epsilon. And once I get those two things, then my definition was complete. My proof was complete. So we're just going to practice a few more of these today. So I believe this was the example we were ready for. Is that right? Okay, so we start with our goal. And that part is really just to kind of help us later on. So if the absolute value of x minus a, what's my a value? 0, is less than delta, then the absolute value of f of x. F of x is your function, it's the thing you're taking the limit of. So that's the cube root of x. Minus L, what's my limit here? 0. Is less than epsilon. So that's what I have to prove. I'm not done until I've proven that. So my first step is to find delta. And we do that by starting with this f of x minus L statement. So the absolute value of the cube root of x minus 0. And we're trying to simplify this. What do you know if you subtract 0 from anything? You can drop that off, right? So this is the same thing as the absolute value of the cube root of x. Absolute value just makes it positive. Does it matter if you do the absolute value before or after the cube root? No. So this would be the same as the cube root of the absolute value of x. Okay, we're trying to turn this thing into this. But isn't the absolute value of x the same as the absolute value of x minus 0? Yeah. You could write that if you wanted to. You really don't have to. I'm assuming we all know that that means the same thing. So write it if it helps you. But we know this is less than epsilon. So if you were trying to just solve for this absolute value of x minus 0, how would you get rid of your cube root? Cube it. So if we cube each side, then my delta needs to equal epsilon cubed here. Step 2 is the proof. So the very first thing you have to tell me is let delta equal epsilon cubed. And then we just rewrite our goal statement up until, oops, I went a little too far. So we're going to rewrite that part. So if the absolute value of x minus 0 is less than delta, then the absolute value of the cube root of x minus 0 okay, we have to work this until we get a less than and an epsilon in there. So working that, it's really just repeating what we already did on the last one. So we know we can drop the minus 0. We can pull the cube root out. Okay, but the absolute value of x is the same as the absolute value of x minus 0. And we already said up here that that was less than delta, right? So right here I can say this is less than, and I'm replacing my absolute value of x with the delta. So it's less than the cube root of delta. But we said delta equals epsilon cubed, so I'm going to replace my delta with an epsilon cubed. So that equals the cube root of epsilon cubed, which is epsilon. So we got our less than, we got our epsilon. We're done. So we have proven this limit. Questions? Let's do at least one more. I've got 2 more, I think, on your notes. We can do them both. We can, whatever we need. So what's my goal? Tell me what I write. If what? The absolute value of x minus -3, so x plus 3 is less than delta, then the absolute value of 7x minus 9 minus -30, so plus 30, is less than epsilon. Okay, so step 1, find delta. So we start with this f of x minus L statement. So the absolute value is 7x minus 9 plus 30. If I start working that out, what can we do? Add your -9 and your 30. And then what? Well, out of 7, it's a positive, so the absolute value doesn't change it, and that gives us x plus 3, which we know is what we wanted, right? So this whole thing is less than epsilon, so what's delta? Epsilon over 7. Okay, if you would just solve for that. So we now can go to our proof. So you have to tell me what delta is. And then we're going to write our goal statement up until the less than. So if the absolute value of x plus 3 is less than delta, then the absolute value of 7x minus 9 plus 30. And then we work this out. We're really repeating the same steps as before. So that's 7x plus 21. You can take out your 7. Well, we know the absolute value of x plus 3 is less than delta, so this is less than 7 delta. So I got my less than in there. Now all I need is my epsilon. What do I do? We said delta equals epsilon over 7, so that's 7 times epsilon over 7, which is epsilon. So we have proven that the limit as x approached -3 of 7x minus 9 does equal -30. Do you guys want to do the last one? Let's go ahead and do another one. Any questions on this one? Alright, so our goal. what's my first absolute value? Absolute value of x minus 5 is less than delta. Then what? Absolute value of 17x minus 35 minus 50 is less than epsilon. So we find delta. Where do you begin there? Then what can I do?
17.
I'll have 17. And that gives me 5. What do you know about that? This is less than epsilon. So what's my delta need to equal? Okay, so for my proof, rewrite your goal statement without the less than epsilon. Oh, what else? What do I have to write for that though? Let delta equal epsilon over 17. Okay. Now we basically do the same work over again. That's 17x minus 85. Pull out the 17. That leaves me with x minus 5. But I know that the absolute value of x minus 5 is less than delta. So this would be less than 17 delta. So I got my less than in there. Now we just need to get epsilon. So we look at this, and we know that delta is equal to epsilon over 17. So that's 17 times epsilon over 17, which is epsilon. So we are done. We have proven the limit as x approaches 5, 17x minus 35 does equal 50. Questions there? So I want to spend the rest of class just letting you guys try these. There's a handout posted on Classroom that has some. So you have the rest of the hour to work. You can help each other, ask me questions, whatever we need to do.